Okay, so in the last theory session, we talked about abstract classes, and this is a programming session to look at an example of abstract classes, an abstract class. So let me make a class. So this needs to be abstract class vehicle, and I'll have int position and int speed, and I'll give this a public void move forward in steps, and I just do position plus equal steps, and similarly a public void move backward and in steps again, and position minus equals steps. So these are the two methods that I've given a definition for, and both the car and the bicycle class are just going to use this definition of for these methods. But let me also have an abstract um, void, let's say calculate maintenance cost, and I won't define this here. And let me now go to the car class. So this is class car, and this one is concrete, and here I have an int fuel and a static int fuel capacity equals, let's say, 100, and I'll have a constructor for the car class, and this just sets the fuel to, let's say, half the tank. And oh, okay, so the car class should extend the vehicle class, and next I'm going to implement the calculate maintenance cost method. So void public void calculate maintenance cost, and here I'll just oh, this should be an int, so an int here too, and here I'll do just return fuel underscore capacity minus fuel. So that's my maintenance cost for this. And in the bicycle class, let's do class bicycle extends vehicle, and inside this, let's say I have an int air capacity equals I'll just make this static, int air capacity equals, let's say, 20, and I have an int air, the amount of air that's in it, and bicycle constructor, and here I just do, let's say, air equals 10, so half again, and now I'll do the public int calculate maintenance cost, and this will just return the air capacity minus air. So what we have done here is, the reason I made calculate maintenance cost abstract here, actually let me just make this public. The reason I made it abstract here is because depending on what kind of vehicle it is, the implementation could vary, but I want to assert that every class that inherits from the vehicle class must have an implementation for the calculate maintenance cost. So that's what I've done here, and I've got both these constructors as well. So let's do a test.java. So I've got class test, and this will just have a public static void main. And so first up, let's just try making a vehicle v is equal to new vehicle. I know I told you this is an invalid operation, but I just want to demonstrate that once. So I do java c vehicle.java, and I do a java c test.java. So here I've got an error. Uh, vehicle as abstract cannot be instantiated. So I just wanted to show you that once. So let's say I have a vehicle car equals new car, and a vehicle, actually let's just keep this to v1, and v2 equals new bicycle, and let's just do a system dot out dot println, and v1 dot calculate maintenance cost, and similarly for v2 as well. So I just copy paste this, and now let's do java c car.java, java c bicycle.java. Okay, I've got an error here. So I've misspelled capacity here, that's the error. And now let's do this again, and java c test.java and java test. So I've got 50 and 10 here as expected. The calculate maintenance cost was uh, done differently, and let me just make this int and have this return the position, turn position, and this would do the same. Okay, here's another point that I don't think I mentioned in the theory session, but abstract classes can also have constructors. So I can have public vehicle, and let's say I have no args constructor, and I just set the position to let's say 10, and the speed actually doesn't matter. Or I could do something like speed times steps, and speed times steps here too, and I can now set the speed to, let's say, 2. So it's going to be twice the number of steps that I pass to it. And alright, so after this let's do a system dot out dot println, and v1 dot move forward by 2 steps, and system dot out dot println v2 dot move forward by 4 steps. So what's going to happen here is that v1 was at position 10, and I've given it 2 steps, so it'll go to speed into steps, so that's 2 into 2, that's 4, so it'll go to 14, and v2 will go to I think I've passed it a 4, so it'll go to 18. So that's what we expect here. Let's just do a java c test and java test. So here I've got 14 and 18 as expected. What I wanted to point out was that since car and bicycle have both inherited from the abstract class, um, they both have the method move forward and move backward. And another thing right here is, let's say I comment out this method and now try to run the code. I do a java c car.java, and here I've got an error. car is not abstract and does not override abstract method, calculate maintenance cost in vehicle. So here they've just asserted that car should extend, um, car should implement the calculate maintenance cost method. So I'll have to uncomment this and then it works fine. And I think this example takes care of most of the stuff in abstraction. Next, we'll have a theory on interfaces and we'll do a programming session on that as well. And later, we'll also have a theory on abstract classes versus interfaces. So I'll see you in next time.